Good morning, everyone. I hope this video finds everyone well. We are moving on with our Trig unit. Today we'll be looking at 34-1 and 34-2. I'm going to split this up into two videos. So this first video is going to be 34-1. It's found on page 511. So go ahead and get to that page, however you've been taking notes. We're going to start off with some definitions here. So if you're still keeping the word wall, these are good to get on there. If you're not keeping a word wall anymore, that's fine. Just be sure to note these vocabulary words. So first of all, a periodic function is a function that repeats its values in regular intervals. So periodic just means some kind of function that repeats. The period of a periodic function is the regular interval of a periodic function. So it's how long it takes the graph to repeat itself, basically. Okay, so we got a periodic function, and if a function is periodic, it has a period. So we take a look at these two pictures here. Which of these is a periodic function, and what is its period? What is the period? So you can look here. This first one is definitely a periodic function. What happens here is we have some repetition, right? Now, one thing with a periodic function, it doesn't matter where you start the repetition, right? So if we look at this being our first point, here we have the little v, and then it starts to repeat. I know it repeats because I can see the distance between this top point and this bottom point, right? It takes 4 units to get there. Same from this top point to this bottom point, so it takes another 4. So that's indication that it's a periodic function. It's repeating. I could have gone from this top to this top. I could have also gone from the bottom to the bottom. It doesn't matter, right? It doesn't matter where I pick my starting point to be, because this function goes left forever and it goes right forever. Okay, so the period of this, again, doesn't matter which period I pick. Let's go from this high point here to this high point here, right? The period of this guy is from -4 to +4, so that's 8 units, right? Whatever it is. So the period is 8. Now, again, period doesn't matter. If I went from this bottom to this bottom, that's still a distance of 8, right? From x being 0 to x being 8, period doesn't matter. Now, the second one, although it does have some patterns, right? It's going up and down and up and down and up and down. It doesn't repeat its values, right? This first point goes all the way up to a little bit above 2, and then this next little peak is right just under 1, and this is just under a 0.5. So although there is a pattern here, and there might be some way to describe this, it's not a periodic function because it doesn't repeat its values. So not a periodic function. So today our biggest goal is going to be identifying whether a function is periodic or not, identifying the period, which we just did back here, and then two other things. Okay, so two more things for the word wall. Amplitude. The amplitude is half the difference between the min and max values of the range of the periodic graph. Okay, so if we go back to this last periodic function we had, the minimum here is down here is at -2, and the maximum up here is at +2, right? So the amplitude is half the difference between them. Okay, so from -2 to +2 is a distance of 4. Half of that gives me an amplitude of 2, right? So I'm going to show you another way, the way I think about the amplitude. If we look at the midline is the horizontal axis about which a periodic function oscillates. Okay, so go back to our first graph here. This line right here is my midline, right through the middle, horizontal middle of the graph. Okay, now we are going to label the midlines as equations of a line. So this midline would be a y equals 0 midline, horizontal line, the y-axis, the x-axis basically. So if you identify the midline first, the amplitude is just the distance from the midline to the top, that's 2, or from the midline to the bottom, that's 2. That's what your amplitude is, right? Half the distance between the high and the low is just going to be from the midline to the top, from the midline to the bottom. So whatever that distance is from the midline to the top or the bottom is your amplitude. Okay, so usually when I'm finding the amplitude, I actually do the midline first, and then I go find the amplitude. Okay, so let's try a few. Let's do this one together, and then I have a few for you guys to try, and then that's it for this section. All right, so this first one, you can see now this black rectangle is not part of the original graph. So the original graph is just this curvy thing here, going up and down and up and down. And that definitely is a periodic function. It goes to the same height, it goes to the same low, all right, down there, and it's repeating itself over the same distance. You can see if I start here on the x-axis and I go here to the x-axis, right, that took about 2 units for that repeat to happen, and here is another 2 units. Okay, so definitely a periodic function. It's going in the same height, the same max, the same min, and it's taking the same horizontal distance to make that repetition. Okay, so what they've done here with this graph is they've just isolated one period of the function so we can analyze it there. Okay, so the one period, that little the square here, I guess it is a square, the period you can see from starting at 0 going to 2 is just 2 units. Now I'm going to go to the midline. Midline here, the horizontal midpoint, right, or the horizontal midline is y equals 4 for this one. So y equals 4 is the midline. And then once I find the midline, I can see the amplitude from the middle to the top, from the midline to the top is 2, from midline to the bottom is 2, so my amplitude is just 2. Okay. So that's it. Identifying whether it's periodic, and then deciding the amplitude, the period, amplitude, and midline. Okay, so you want to pause the video here. This is on page 512. Let's try this one. If you want to pause the video here, try this one on your own, and I have 2 more on page 513 that I think are good to try. But let's try a pause here, try 512, see if it's periodic, and if it is, determine the period, the amplitude, and the midline. Okay, so this is definitely a periodic function. You can tell because it's going to the same height, right? It's going to the same lows down here, and it's taking the same time for that, same horizontal distance for that to happen, right? This is 4 units to get from the low to the high, another 4 units to get from high to low, another 4 units to get from low to high. So everything here is following the pattern. And the values are repeating. So it doesn't matter which period you pick, right? If you just want to focus from here to here, that is 1 period, and the units there horizontally travels 8 units. Okay? Now midline, again, I kind of skipped down to that first. If I find the middle of these 2 values, this goes down to -4, this goes up to 2, right? So halfway between that is actually here at -1. Right? So y equals -1, that's my midline. Once I have that, I can go back and find the amplitude, the distance to the top, the distance to the bottom. Now, if you're doing this correctly, if you have the correct midline, the distance to the top and bottom has to be the same. So it's 3 down, it's 3 up, and that's my midline. I'm sorry, that's my amplitude. 3 up, 3 down gives me an amplitude of 3. All right. So that's what we want to be able to identify today. Okay, now if you want to pause the video again, on page 513, there's 2 problems, 4 and 5. These are the last 2 we're going to do in this section. Take a second, see if you can identify if these are periodic or not. If they are, identify the period, the amplitude, and the midline. All right, so number 4 here on page 413 is periodic. It's repeating its values, it's taking the same amount of, same horizontal distance for that repetition to happen. A lot of different places you can start and stop here. You can start here at the top and finish back here at the top. If you wanted to start down here and finish down there, that's fine too when you're finding the period. I'll go from top to top. That's taking me a distance of 3 units, so my period is 3. Actually, I'm going to keep that all blue. All right, so from this top point to this top point is my repetition. It took 3 horizontal units. My midline, right? So if I kind of looked here at where the midlines happen, I got up 6 is my highest, -2 is my lowest. Halfway between 6 and -2 is +2. So y equals positive 2 is my midline. And then once I have the midline, to find the amplitude, the distance from the midline to the top and from the midline to the bottom. A good way to check myself here, those need to be the same. The amplitude is 4 units. So the only one that needs an equation here right now is the midline. We need that to be a y equals equation. It will always be a y equals for right now. And number 5 here is not a periodic function. And the explanation would be, we could say something like because values, I guess complete sentence, the values don't repeat. And by values we mean the y values, right? This y value is going up to almost 1, then it's a little above 1, then it's a little above 2, and then it keeps going up. So like one of the previous graphs we saw, this is a pattern. There is something going on there, but it's not a periodic function. So if it's not a periodic function, you can't do any of these things there. All right. So that's it for 34-1. There's a worksheet posted. Go ahead and check it out. Check the answers that are posted under homework solutions, and once you're done with this worksheet, submit it. You can watch the second video and then do both worksheets at the same time, or you can pause now, do the video, and then do the worksheet and then watch the second video later. Up to you. I am posting the second video now, so make sure to watch that as well and do the second worksheet.